For this section, we're going to review scientific notation. Now, if you remember from math class, scientific notation is just a shorthand method of writing larger numbers using the base number 10. In order to write in scientific notation, we first need to count the number of digits over from the decimal place. So if we look at our first example, we have 125 billion. If we count over starting from the right to the last number, we'll get our exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is where we're going to stop, right before the last number. And we had counted over 11 spots, so that's going to be our exponent, 11. Now to write this in scientific notation, you're going to first write out all the digits that you used, and the non-zero numbers. So 1.25, we stopped right before the 1, so that's where our decimal is going to go. Then we're going to multiply that by our base number, which is 10, and we're going to put that to some exponent, which was the number of places that we moved, which we found to be 11. So our scientific notation is going to be 1.25 times 10 to the 11th. Looking at the next example, we have 0.000000000456. That's an extremely low number. This is going to be reverse scientific notation, or negative exponents. We're going to count over from the decimal place, but this time to the right. If you can remember that going to the right means you'll have a negative exponent, it'll help you out in the future. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where we're going to stop, right after the first digit. So our answer is going to be 4.56 times our base number, which is 10, to the negative number of places that we moved to the right, which in this case was 10. 4.56 times 10 to the negative 10. Now if we were to multiply these two previous numbers, 1.25 times 10 to the 11th, and 4.56 times 10 to the negative 10, we'd get a new number, and we need to make sure that we keep that in our number of significant figures. In the first number, we again have 3 significant figures, and in 4.56 times 10 to the negative 10, we also have 3 significant figures. So if you remember from significant figure math, when we're multiplying, we're going to keep the lowest number of significant figures. Seeing how they're both 3, our answer is going to have 3 significant figures. Multiplying those two together gets us an answer of 57. 1.25 times 10 to the 11th times 4.56 times 10 to the negative 10th equals 57. Now, we wouldn't keep just 57 because that would be 2 significant figures. We add the 0.0 so that it's 3 significant figures. This concludes this section of our unit. If you have any questions, please feel free to email me.